So now that we have all of these wonderful input devices and output devices, how are we going to connect them to our computer? Well, we use ports, which these are also called jacks, as an interface to which a peripheral device attaches to or communicates with the system unit or other peripheral devices. There's a USB port, as shown right here. USB ports can connect up to 127 peripheral devices with a single connector and transfer data at rates of up to 200 million bits per second. Another type of external bus is a FireWire port, as shown right here. This bus standard supports data transfer rates of up to 400 million bits per second and can connect up to 63 external devices. Now what's nice about USB is that it supports plug and play and hot plugging. Plug and play refers to the ability of a computer system to configure expansion boards and other devices automatically. So essentially, if I plug a brand new printer into my computer via the USB port, my computer will kind of recognize it and configure it appropriately. So let's say my computer doesn't have a port that I need. Well, right here shows a portion of the motherboard. These are called expansion slots. I can add ports to these expansion slots. The card with the port on it will slide right into the expansion slot. Then when I plug, let's say, my printer in, my computer will automatically recognize it via the plug and play. But the hardware installation, they need a set of instructions. The set of instructions that the computer holds is called drivers. These drivers communicate with the computer's operating system. So laptops don't really give you the ability to be able to add all of these ports. So that's one benefit of having a full-blown desktop computer. There are several factors that are going to affect the performance of your computer, one of which is the microprocessor. Now remember, the microprocessor has many transistors. And remember Moore's law that says every 2 years the amount of transistors on that microprocessor chip are going to probably double. So as your software updates and upgrades, you're going to need a larger microprocessor to be able to handle all of the new instructions. And when I say larger, I just mean larger in capacity, not larger size. So newer microprocessors are going to process things way faster than older ones. So while one instruction is being executed on the microprocessor chip, the next instruction is fetched from memory and can be decoded. Therefore, the faster the processor, the more instructions per second it can process. RAM can also affect their performance. Memory, so it's random access memory. If you don't have enough memory, it will overflow to the CPU, which therefore will take longer. So in other words, all of the data and all of the instructions, if there's too much and it can't fit on the RAM, the CPU will store the data on the hard drive, and it slows down the processing cycle because it takes longer for the CPU to read from a hard drive than from RAM. Next we have the hard disk. The size and speed of the hard disk can also affect the performance. The bigger and faster the hard drive, the faster it can process data. And lastly, we have video. The video device connected to the computer can enhance or slow down the computer's performance. So make sure you've got adequate video memory.